Hey guys, so I was building some prototypes for my radio telescope, and the thing I built is kind of cool on its own, so I'm going to show it to you guys real quick. So I got this little pan tilt servo with a distance sensor glued to it, and a little NVIDIA Jetson kit here. And what this does is it sweeps across, and it takes a distance reading as it sweeps, and then goes up, and it makes an image that I can display on my computer. So when I do this for my radio telescope, this is going to be, you know, the strength of a radio emission coming from the sky, and then I'll map that as a brightness value onto my computer program, and hopefully I'll get an image. But with depths, it's kind of cool because I can do some math and figure out where that point is in 3D space, and then map it in a 3D application. And then I can get an actual three-dimensional map on my computer that you can play around with. It's kind of cool. So I got the program up here on my computer. I wrote it myself, so it's a little janky. But as you can see, you start it, start scanning across, and on the screen here, it starts writing an image. That's super hard to see with the colors washed out on this camera, but I'll show it to you guys in a minute. In the meantime, I can show you guys how this sensor works here. If I just switch over to my infrared, so as you can see, this thing not really a laser, even though it's advertised that way on the internet. It's got like an LED on it, and I think it uses a time of flight sensor to figure out how long it takes for the light to bounce back off the wall. Alright, so we're done recording. This is the area that we were recording at here. So you can see we got this bag hanging off the wall, a couple extension cords, a flat wall behind it. Hopefully that's what our picture represents. And if you can see it, boy, this is even terrible on camera. Here, I'll cut to this and film it on something else. Alright, so in our 3D representation here, you can see that right here, there's the bulge from that bag, and a flat wall behind it. Let me rotate it there. So you can see a flat profile, you got the bag hanging off of the wall there, and then you can start to see some of those extension cords off to the right there, drooping down. So, I mean, is it perfect? No, but that's a pretty good 3D map there for like a $5 depth sensor you get off of Amazon. I don't know, what do you guys think? Let me know. Thanks for watching. I guess I'll see you in the next one. Alright, so the rest of this is just for you math nerds. I kind of need your help here. Alright, so we know this distance here on this triangle, heading out in the direction of Z. So you can use your rotation on your pan right here, this little angle, and you can solve for the cosine. It gives you this intermediate value, which doesn't really mean anything, except that you can then use this as the hypotenuse and your rotation on the y-axis to solve for your height, on how high that point is in real space there. So, and then with your distance value and the angle on your pan, you can do the sine and get this opposite angle here, this opposite side, which is your distance on the x-axis that you've moved, right? So, because we know that these two lines are going to be identical because they're opposite sides of the same system here, if you map this out, we know that this line here, the height on the y-axis is the same here where it intersects the plane as it is where the point is in 3D space. So you find the distance on the x-axis and the height on the y-axis, and then you have to find the depth on the z-axis. So that intermediate triangle that we had before, you solve for this leg right here, this line that doesn't actually go to anything. If you use the sine of this one, you get the distance on the z-axis to the y-intercept point here, and that's going to give you your actual depth off of the plane when you're projecting it on the computer. So this works okay for my program, but I still get distortions on the wide field when I go out to the edges, or if I'm looking up underneath of something that's flat and coming back towards the camera, it starts to curve down. So I don't know if that's just a sensor issue or if there's something wrong with my math. So this is it if you're going to look at it in code. So the first thing I calculate is that intermediate value that we need to solve for the depth and the y. So I call that W, is the cosine of your pan degrees times the distance that you measured. And then your x is just the sine of the pan degrees times the distance you measured. And then y coordinate is going to be the sine of the tilt times that intermediate value that we just calculated. And then for your z, it's a little weird down here, but it's just the cosine of the tilt times that intermediate value that we calculated earlier. And the rest of this here is just my shortcut to get that to always be a positive number. That's an absolute value hack.